Okay, so if you guys remember the slope formula for the warm-up here for page 6, remember that slope formula, if you needed it, was y2 minus y1 over x2 minus x1. And we'll be doing this on the graph later, so we'll talk about how to do it on the graph. What is the slope of a line parallel? What is the slope of a line perpendicular? If you need the distance formula, it's the square root of x2 minus x1 squared plus y2 minus y1 squared. And midpoint, remember another word for midpoint that we talked about was average. So it's just add the x's and divide by 2. Be careful you don't put the y's in front. Should be x's first. All right, so see if you can work through those real quick if you haven't already. And then we'll check those in a second. If we take a look at the first one, letter A here, we did the slope. So remember, changing y over changing x, you're going from essentially 4 to 12, which means you're going up 8, right? 12 minus 4 is 8. And then you're going from 3 to 5, which means you're going up 2. So plus 2, 5 minus 3 is 2. And then 8 over 2 is 4. So there's your slope. If you had a line parallel to that one, it would have a slope of 4, because parallel lines have the same slope. And if it was perpendicular, it should be good. A to negative 1 over 4. Remember, invert, so negate, and then flip that over for negative reciprocal. Kalena, we did the distance formula. So if you do your distance, x2 minus x1 squared, y2 minus y1 squared. If you wanted to think about the change here as being 2 and 8, you could also just do Pythagorean theorem with the 2 and the 8, and you'll get the same answer as the distance, okay? If you plug it in, x2 minus x1, 5 minus 3 is 2 squared. y2 minus y1, 12 minus 4 is 8 squared. That's the same thing, right? And then what's 8 squared plus 2 squared? So this turns into the square root of 68. No need to simplify. No need to put it as a decimal. Just leave it as the radical, okay? And then the midpoint, same deal, average, add the x's. Careful that you put the x's in front and not the y's. It's an easy mistake to make. But what's the middle of 5 and 3? 4, right? 5 plus 3 is 8 divided by 2. And the middle of 12 and 4 is 8. That's 16 over 2, so that's 8. That's it. That's what you need to know how to do for today. If you can do those 4 things, really A, D, and E, we should be good. Okay? Yep. Down to question number 1 below then. So what we're going to do is we're going to talk about how do we take 4 points on a graph and show that these 4 points create a parallelogram. That's our goal. Okay? Now, here's the deal. Moving forward, I am not going to ask you a specific way to do this, but there were originally 6 properties of parallelogram that we talked about on page 2 in your packet. You guys see page 2. We're going to talk about 4 main ways to show something's a parallelogram. So Robert, tough to do on a graph, but you can't really show that the opposite angles are equal on a graph. It's kind of hard to actually get the measure, and it's kind of hard to see that the angles next to each other make 180. So we're going to kind of leave those 2 off. We're going to say, look, just show me that the opposite sides are parallel. And if you're using parallel, you need to use what formula? Parallel lines have the same. What's it called? Slope. Use the slope formula. We can show that opposite sides are congruent. And guys, look at your notes. Look right next to it. Right here. I already put the formula down for you. If you do opposite sides congruent, you want to use the distance formula. If you want to show the diagonals bisect each other, in order to bisect, they have to cut each other at the midpoint in the middle. They have to have the same midpoint. Or you do one pair of sides congruent and parallel. Your job is to know one of these and have this as a go-to. So when it says, show it's a parallelogram, you're going to be like, bro, my game, slopes, I'm doing opposite sides parallel, and we're rocking it. That's all you got to do, okay? Pick one as your go-to, and make sure you know how to do it. Today, we're going to kind of go through the different methods, but moving forward after today, you'll be able to pick which one you want. This first one, we are going to use opposite sides parallel, okay? So we have to use it for this question because that's what it says. What I'd like you to do is start off by just graphing those 4 points, okay? So do that first, and then we'll come back together. Once we've gone ahead and graphed our points, we connect them with lines, make sure you label them. So we're starting off with A down here at negative 4, 5, negative 5. B is 3, 1. C is 2, 4. And D is negative 5, negative 2. Okay. Our job is to show that opposite sides are parallel, which means we need to calculate the slopes. Now, we could use the slope formula, or, because there's a graph, we could just count it. So if you're going to use the slope formula, by all means, go ahead. Otherwise, what I want you to do is connect the rise and the run to make a right triangle right next door to it. And be sure to label the sides and the number of boxes for each of those lines. Okay. How many slopes are we going to be calculating? 4. So make sure you can know which one's which. What I like to do for that is I write M, because that stands for slope, and then the 2 points I'm doing the slope of, like the first one here is AD, I'm going to put a little subscript, a little small AD next to it. So I know that that's the slope of AD. Okay? It helps keep track of things and makes it a little easier to do. Now, careful with directions. If you want to add arrows to your lines, how am I getting from either A to D or D to A? I'm going... Okay, now, I would say, like if I'm going up 3 and over 1, which direction are you moving when you say over? So it's technically up and left, or down and right, which means that this is a... Up 3 means positive 3, but left 1 means... So this is a negative slope. You got to be careful with the signs, okay? It's easy to mix that up. Now we're going to do another slope. What's the next line you want to do the slope for? DC it is. So I'm going to draw a line going up till I get to where C would be, and then across. We'll count the number of boxes. So that's 6 up. And then moving to the right, how many spots? 7. So the slope, small m, small dc, rise over run is 6 over 7. Careful that you put it in the right order. Rise over run. Okay? Taylor, we're going to go to the next one. So from C to B, I have to move right and then down. So what happens if I go right and down? What happens to that slope? It's supposed to be rise over run, correct? If I go down 3, what type of number is that? Good, Taylor. So negative 3. And then the run is to the right 1, so that's positive 1. Does that match the side across from it? Is 3 over negative 1 the same as negative 3 over 1? Yes, as long as one number is negative, the whole fraction's negative, okay? And then the last one we got was to go from A to B. So we were going right and then up. Still the same thing, correct? And then still 6 over 7. Okay. Now, notice that we're not doing a 2-column proof. You don't worry about drawing the 2 columns here. Okay? Makes sense so far. I've shown what the slopes are, so I've done a calculation. I need to just say something about this calculation. What does this show us? If these 2 slopes are equal, what does it mean? They're parallel. So I'm going to say immediately off to the side that AD is parallel to, what's the other line is parallel? BC. And then I'll put a comma. And not only do I know that AD and BC are equal, but I also know that, good, AB and DC are parallel. Now, this is kind of like a statement in your proof. And if you have a statement, you need a reason. So what is the reason why we know these are parallel? Same slope. Same slope. Or slopes are equal. That's it. Okay? So notice what we did. Graphed it. labeled it, calculation, said something about the calculation. Is this enough work to show it's a parallelogram now? If this line is parallel to that line, and these two lines are parallel, does that guarantee me to be a parallelogram? Yeah. So now I can write my summary statement for the whole thing, which is, what's the name of the shape? Now we name it with the letters. So what's the name when we wrote the letters together? It's also in the question right here, guys. So we say A, B, C, D is a parallelogram. And just like as a proof, we're going to end with our statement and reason. Because what property did we just demonstrate? What do you mean the sides? Which ones? Good, because opposite sides are parallel. That is all you have to do for a coordinate geometry proof. That's it. Okay? Graph it, show the work, state slope, distance, midpoint, say something about the calculation, and then tell me about your shape here. All right. If you got that done, would you please go to the next one? Go ahead and graph your points, draw and label. Pause it here and try it on your own real quick. Probably recommend when you're doing this is to graph the points and then put the letters on, just so that you know you're putting them on the outside so you don't draw the lines through. But your call. Now, for this question, we are going to show that this is a parallelogram, and we're going to use opposite sides equal in length. In order for the lengths to be equal, what do we really need to know about these sides? What do we actually have to calculate? But what calculation tells us the length of something? Okay, but what is it actually doing if you're doing the Pythagorean theorem? Nope. On the warm-up, what question on the warm-up is technically would you use to do the length? The distance. So when it says equal lengths, that technically means that we want to do the distance. Now, I heard you guys say before we can use Pythagorean theorem, and you're absolutely correct. And there's kind of a reason why we're going to do Pythagorean theorem. It's a little bit of a shortcut. If you would like to use the distance formula, please feel free. But how many distances are you going to need to use to do? 4. If you do the Pythagorean theorem. Now, when we do Pythagorean theorem, we're still going to use the slopes, meaning the rise over run, but you can kind of ignore the sides. So notice that how many units is this side going up in the triangle? 4, and this side has a length of 3. So when I do Pythagorean theorem, you guys agree to do a squared plus b squared equals c squared. What am I plugging in to figure out the length of AD? 4 and 3. So 4 squared plus 3 squared is equal to c squared. What is 4 squared plus 3 squared? Now, what's 7 squared, though? What is it? But what's 4 squared? 4 times 4 is 16, and 3 squared is 9, right? So be careful. You have to square these before you add them together. Remember our PEMDAS. Good. Equals c squared, and then 9 plus 16 is... And remember, in order to get c, because it's c squared, we have to square root it, which means we're going to get it actually going to be a length of 5. Now, we've done the Pythagorean theorem. We actually need to identify the distance, what this means. So, but wait a minute. The reason why it's a shortcut is because not only does these two sides for AD have sides of 4 and 3, but so do BC. When you draw this right triangle for points B and C, you're also going to get sides of 4 and 3. So we don't need to do the Pythagorean theorem again because we already have it. What we're going to do, though, is underneath, we're going to put down the distance of those two sides. We do lowercase d for distance, and then we put AD and BC for our little subscript there. And then what are those two distances? They're 5, because that's what we got when we did the Pythagorean theorem. So after you do the work, you're going to tell me what the distance is. You're going to actually say it. Does that make sense? We okay with that? Pythagorean theorem, calculus the distance, and then we actually say that what the distance of those two sides is. We're going to do the same thing for the other two sides. So for AB, how far over? Down. Good. 8 over and 3 down. And that means it's the same thing for the bottom. Make sure that when you're doing this, you're drawing those right triangles and you're labeling those sides, okay? That's your work. That's showing work. And then you're just going to do your 8 squared plus 3 squared. Yep. And then 8 squared is plus 9 is. And then if that's equal to c squared, c is. Now, do we really need the decimal? Just the radical is fine. Okay, keep it simple. All right. And then we're going to say that the distance of, good, AB and then CD are the square root of 73. Okay. Now that we've done the calculation, we've stated what the distances are. We need to say something about this work. So what does this specifically demonstrate? If the distances are equal, the sides are not parallel, but congruent, parallel slope, okay? So we're going to now just say real quick that AD is congruent to BC, comma, AB is congruent to CD. There's the statement. What's the reason for this? Now, not because the sides are equal. What did you show right here? Yes, distances are equal. Okay? And did we do a final summary statement for the question? What's the summary statement supposed to be? That this thing is a parallelogram. So we just have to end by saying that. So work, right? Put down what you're trying to show, say something about it, and then your summary statement. So A, B, C, D is a what? And then there's your statement. We need a reason. So what property did we just show? What are equal? What kind of sides? Where are they located? Opposite sides, very good. Opposite sides are equal. Okay? You don't have to say distances because we already said it in the last part. So just opposite sides, just the property. Okay? That's it. Nothing too crazy. Okay? Graph it. Calculation. State what the distances, slopes, or midpoints are. Say something about it. Summary statement for the proof. Go for it. Okay? All right. We're going to do another one here, number 3. So go ahead and graph that for yourself first. All right, pause it, do that now. Hopefully you've graphed, you've drawn the lines in for yourself and labeled. So we have MATH. This time, we're going to do it a little differently. We're still going to show it's a parallelogram, but we're only going to use one pair of sides and show that it's both parallel and congruent. Remember, parallel means we need to use the slopes, very good. And congruent means we need to use the, we're doing the last question, we want to do congruent. Pythagorean theorem, which gave us the distance. Good, okay? So, pick two sides that are going to be parallel and equal. AT and MH. We're going to do AT and MH then. If you want to do the other two, go for it. Doesn't matter. But we're going to draw in the rise and the run then. So how do I go from A to T? Go over 8 and rise 1. So remember, that means off to the side, we're going to say that the slope of AT is 1/8. And the slope of is also, and because we've said these two numbers and they're the same, what can we now say about those two line segments? They are, careful, slopes parallel. Good. And remember, statement, we need a reason. What did you just demonstrate? Slopes are equal. Good. Same slopes or slopes are equal. Awesome. Okay. Now that we have one, we have parallel, we also have to get congruent, which means we need to do the, in order to do distance, we're going to do Pythagorean theorem. Go to a squared plus b squared equals c squared, okay? So what numbers are we plugging in for a and b? You got it. And so 8 squared is 64 plus 1 is 65. And so the actual distance is, what do you do to get c if it's c squared? Square root it. So square root of 65 is what c is. So underneath, the distance of AT is, what do you mean that's incorrect? Good. And the square root of an MH, that distance is also the square root of 65. And then we can say, what about those two sides? That they're congruent. Good. And they're congruent because the distances are equal. All right? And then, do we have enough now to say that it's a parallelogram? So we make our summary statement. So MATH is a parallelogram because, and what did we just show? You got it. One pair of sides, you can say opposite if you want, is congruent and parallel. Okay, there's one more. We're going to talk about it. We usually don't use it a lot, so you don't necessarily need to know it per se. Okay, you need to know the property and the formula, but you're probably going to not end up using it. And that is for number 4. If we want to show that the diagonals bisect each other, what do we really need to show about these two things? In order for the diagonals to bisect, that actually means they have to have the same, midpoint. Only because I don't necessarily know that they cross on the y-axis, okay? All right, now if we graph these points for ourselves real quick, okay? So the point 2, 1, 3, 4, 5, 6, negative 6, 7, negative 2, and 1, negative 3. We get BEAM here when we're going around in a circle. We can draw and connect those points together. All right? And then all we're going to do is we're going to do the midpoint. Now, if you want to do like mid-PT for midpoint, or MP, it's up to you. I feel like that's off a little bit, doesn't it? Oh, you know what? This is supposed to be 1, negative 3. This guy's off. 1, negative 3. All right, that looks a little bit better. Okay. So, what do we do in the midpoint of again? Remember, we're doing the diagonals. So what 2 points form the diagonals? Corner to corner, guys.
B and A.
B and A. So AB is one of them. And then the other one is, good, ME. Now, midpoint, remember, was like average. So we're going to add the x's, okay? So if we add the x's for AB, that's 2 plus 6 over 2. And then 1 plus negative 6 over 2. Your other option is to kind of think about it like, how do I get from A to B and then do half? So how do I move from A to B? I go down how many? From A to B, 7. So instead of going down 7, I'm going to go down 3 and a half. And instead of going over 4, I want to go over 2. And where that point is, that's down 3.5 over 2, that's the midpoint. That's how you can kind of use the graph. If you use the formula, you just add 2 plus 6 is 8 divided by 2 is 4. And then 1 minus 6 is negative 5 over 2 is negative 2.5, or we just leave it like this. If you do ME, okay, same thing. We're going to do 1 plus 7, which makes 8. And the half of that's 4. And we're going to do negative 6, right? Plus 1, which gives us negative 5. And we get the same thing. So that means that AB and ME bisect each other. Because they have the same midpoint. And then we can make our summary statement. I'm going to let you guys finish this one up. Your homework tonight is on the next page where it says homework. You're just doing question 1 and 2. Okay? So for question 2, you have to use slopes. For question 1, I believe that you can do whatever you want. Okay? All right. Have yourselves a great day. We'll see you tomorrow.